An arithmetic series that has first term A and common difference 2A, where A is not equal to 0. A geometric series has first term A and common ratio of 2. The k term of the geometric series is equal to the sum of the first 64 terms of the arithmetic series. Okay, so we look at that. AP has a first term A, and every time you just common difference of 2A. So I'm just going to write this down, that 3A, then add 2A, 5A, and so on. The GP, you have first term A, common ratio of 2 times 2, so it's 2A, 4A, and so on. We were told that the k term of a GP is equal to the sum k term of the GP. We know that this is just A R K minus 1. So in this case, is A R 2K minus 1 is equal to the sum of the first 64 terms of the S64. Okay, so we just write this down. So given that A 2K minus 1 is equal to sum of 64 terms of the AP. This is AP. Yeah? So what you do is A 2K minus 1 is equals to 64, which is 64 divided by 2. 2A plus 6n minus 1 D, which is 2A. There you go. Then you just expand this and solve it, right? This will be A 2K minus 1. 64 divided by 2, that will be 32. This is 2A plus 63 times 2, which is 126A. There you go. So this is the case here. So cancel off the A. Left with 2K minus 1, 4096. Can long both sides if you want to long both sides. Then solve it. This will be K minus 1 equals to ln 2. Ln 4096. K minus 1 is ln 4096 divided by ln 2. Okay, so K is equals to 12 plus 1. K is equals to 13. I think this is okay. So for part B, a GP has a first term F and common ratio R, and F is not equal to 0. First term is not 0. The sum of the first 4 terms of a series is 0. So S4 is 0. Find a possible value of F and R. Find also, in terms of F, the possible value of the sum of the first n terms of the series. I think this is pretty okay. Just write it down. I'll write this down, which is GP. The first term is F, common ratio R. So multiply by R, FR, multiply by R, FR square, and so on. Okay. We're told that the sum of the first 4 term, S4, is 0. So S4 would be A Rn minus 1, R minus 1 equals to 0. So we know that the first term is F, so F Rn minus 1, R minus 1 equals 0. So by solving this, S4, this is, sorry, S4. This n is 4. Okay, great. So this case here, what we get is, we know that F is not equal to 0. So we know R4 is minus 1 equals to 0. So R4 equals to 1. So this case here, what we get is R is equals to 1 or minus 1, right? We need to consider, because we are told to find the possible value of F and R. Okay? So the first thing is, maybe here, the reason why they put S4 because it's easier. So if you consider this, right, S4, if the first term is F, the second term is multiplied by 1, the R is 1, right? Then it will be, the second term will be F again. Then this will be still F plus F. So essentially, this case here will be for F, which is not equal to 0, since F is not equal to 0. Okay? So hence, R cannot be equals to 1. Check. you reject this solution here. Because if you take r equals to 1, you S4 will definitely be 4f, which is not what you want. Okay, so if this case here, if the r is minus 1, yeah, then this is minus f. Then multiply by minus 1 again. This is plus f. Then multiply by negative 1 again. Then this will be negative f. This will indeed be 0. So hence, r is equals to minus 1. Okay. The thing now is S4 is equals to 0 regardless of the value of f. Okay. This is what we can state. It's independent of the value of f, right? So essentially, hence r has to be equals to negative 1, and f is any real value but 0. Okay, so essentially this is the case. Or you can just write down like that. You can just write down that f minus 1 r real value and okay, we are told to find the possible value of the sum of the first n term. So Sn, we know that Sn is given by f 1 minus r, which is negative 1n, over 1 minus minus 1 minus r. So this will be f over 2 f. Okay. In other words, right? In other words, you can write this way because we know that it's either f or 0, right? So Sn is 0 or f when n is even, when n is odd. Okay, it is only these two cases here. So you can write this, of course you can write it in this form here in terms of n, or you can write it this form here. Works as well. Piecewise or this way, it doesn't matter. Okay, so the first term of AP is negative. The sum of the first 4 terms of the series is 14, and the product of the first 4 terms is 0. Find the 11th term of the series. I think this is pretty okay, right? First term of AP is negative, so A is less than 0. So the sum of the first 4 term is 14, and the product of the first 4 term, T1, T2, T3, T4, is 0. Oh, sum of the first 4 term is 14. 11th term of a series. Okay, I think this is pretty okay. I have T1 plus T2. Or maybe I just write this down. 2A plus 4 minus 1D equals to 14. I think the main thing here is to use zero factor theorem. So your T is A, and then this is A plus D, A plus 2D, A plus 3D equals 0. So this case here, what you need to understand is that either this is 0, this is 0, this is 0, or this is 0, right? So from here, what I'll get is either A is 0, A is minus D, A equals to minus 2D, and A is equals to minus 3D. The thing now is I need to check. So we slowly go down the list. I think A equals to 0 is rejected because as A is negative. That's important. I'm just going to sub all this A into this guy here. So A is equals to 7 minus 2A minus 7 minus 3D over 2. D is equal here. D is equals to minus A, right? So we just put this in. 2A plus 3 minus A equals to 7. Essentially, I just find the value of A. We just find which one is negative. There you go. So I think so I replace, when A is minus D, I replace D equals to minus A into this equation here to find out my value of A. So this is negative. This both will yield positive. So reject as A is positive, is negative. We're told that is negative. So T equals minus 7, D equals to 7. So T11 will just be minus 7 plus 11 minus 1 multiplied by 7 is 63. Okay, the 11th will be 63.